What I like about this class is that we dig into the tough issues, those things that are really um, moving the needle as far as public policy and business decisions. So our example today is about Oreos, and are double stuffed Oreos really twice the stuffing as single stuffed Oreos? Clearly I'm being facetious here, but it's a nice simple example to get our heads wrapped around. So what we have in column A are 30 weights of just the filling of a regular stuffed Oreo, and in column B is 30 weights of um, a double stuffed. This is a very typical format. Right? You've got two columns with two variables. The downside of this structure is that it looks like somehow this one on number 2 went from 3 and is now 6.1, because normally things that are on the same row belong together. And what we have here, these do not belong together. This is a really common structure, and this is a structure that Excel likes, but it's actually not the best way to present this data. A much better way is using what's called the tidy format. So I have that same information here. This looks a little bit weird at first, but what we have is all of the masses in one column, and then all the kinds in another column, right? So this was one Oreo, and it was regular stuffed, and it weighed 3 grams. Over here, this was one Oreo, it was double stuffed, and it weighed 6.21 grams. This is a much better format. And this is the format that modern programs like Tableau or Power BI use. The other nice thing about this is we can really easily do a pivot table to get our summary statistics. So I'm just going to go to Insert and Pivot Table. It automatically selected the range of the data. It's great. So now I've got these different options to build my table. I want my rows to be kind. So my kinds are double stuffed and regular stuffed. And then this one that says mass, I'm going to drop here in values. You can see it gave me the sum of mass broken up by double and regular. I'm going to drop it in a couple of times. All right, so we've got the sum 3 times. By clicking the I can change that. So I'll do average. Now I've got the average. I will do standard deviation. And finally, I'll do count. All right, so I have now made very easily some summary information about the data. It's very easy to do because my data was properly formatted like this. So I've got my double stuffed and my regular. All right, so question 1. Our double, is the filling the same, or is it, let's say it this way, is there more filling in a double stuffed Oreo than a regular stuffed Oreo? So my claim is that there is more stuffing in a double stuffed than a regular. Right, so I'm going to say the double stuffed is greater than regular, that the average here is bigger than this average. So this is the data, and let's just go through this process. I'm going to go to XLSTAT, parametric test, to sample, t-test or z-test. We have 30 of these, so we can do a z-test. The way that I like to do it, the way that I've kind of set this up in my head, is I want to know if double stuffed is bigger than regular stuffed. So my sample 1 is going to be double stuffed. Sample 2 is going to be regular, right? Even though this is column A, B and this is column A, I want to see this. And under options, I'm going to say sample 1 minus sample 2 is bigger than 0. That means double stuffed minus regular stuffed is more than 0. Therefore, double stuffed is bigger. That's what my alternative hypothesis is here. Here, I've got one column per sample. So everything in this column belongs to the sample. Great. I'll hit OK. Continue. And it's done some stuff for me. This is the same information that we got, regular stuffed. We get the mean, standard deviation. That's the stuff that we calculated ourselves using the pivot table. All right, so our observed z-value is 95. So the null hypothesis is that the weights are equal, the amount of stuffing is the same, or it's equal than or less than 0. So, or that the weight of the single is more than the weight of the double. The alternative is the weight of the double is more than the weight of the single. And, oh, I did this in a reversed way. I think XLSTAT makes this really confusing. Let's go back again. All right, here we go. So yeah, we are now going to be able to conclude that the weight of a double is more than the weight of a single. Right? We can see in our box plots, it's more, it's statistically significant. So ta-da, a double stuffed Oreo does have more stuffing than a regular stuffed Oreo. Great, easy peasy. But the word double implies 2 times. So is a double stuffed Oreo 2 times the amount of stuffing as a regular stuffed Oreo? We can find that out too. Let's go 2x. Right, so this is 2 times the regular stuffing. I'm going to do equals the mass of my regular times 2. Just carry that down. So now I'm going to compare, are these two things the same? Okay. Go back to an XLSTAT parametric tests. I've got column B. I'm going to switch from this column on my second sample to column C. I'm going to change this to equal. So is there a difference between these two things? And we get a z-value of -1. So -1 is not bigger than our critical value. You can see here that they look very similar. And so since our z-value is small, it's not bigger than our critical value, which would be 1.96, there's not evidence here to suggest that there's a difference. So we will conclude that there's not enough evidence to say that they're different. So we fail to reject the null hypothesis that they're different, or that they're the same. So our null hypothesis is they're the same. We fail to reject that. Right? There's not evidence to say they're different. So it does look like they're the double stuffing in an Oreo is double a single Oreo. There we go. So we did this using our 2-column format. We can actually do the same thing using our 1-column format. In XLSTAT here, instead of saying we've got 1 column per sample, we're going to have 1 column per variable. You can see this changed. It says sample identifiers. Watch it change. Sample. So my data is going to be in this column, and my identifiers are this column. This is just checking regular versus double. Are they the same? And we can see clearly that no, they are not the same. Right? The weight in a double is not the same as the weight in a single. So just showing that you can do it using this format or this format. Either one works with XLSTAT. One final way to do this is if you go to Data, you can have the Data Analysis Pak, which is available here. I'm going to do z-test with two means. It's going to ask for my variable range, so that's, I'm going to put this, that's fine. We'll just leave that here. It asked me for the standard deviation of variable 1 and 2. So in order to do that, that's why we needed our pivot table. I really hate Excel. That version, so here are the values that we need. I'm just going to copy these so I can see them here. All right, so 1 is 0.105, and this one is 0.142. Gracious. Here. And just change spreadsheets on me. Here. There we go. So whether or not they're the same, we get the same outcome. That no, there's not evidence that they're the same. Right. Okay. So what I had done wrong was I put in the standard deviation when it wanted the variance. So I just squared standard deviation to get the variance, and then we get the exact same result we got using XLSTAT. Just another example of why using XLSTAT is a lot easier than using the one that Excel provides to you called the data pack. All right, so this was testing two means to see if they're the same or different using Oreos.